Right. We saw authentication in EIGRP. We used key ID and key string. Key ID also should match with the neighbor. See, when you enable authentication, this key ID and this key string, they work together. I cannot put key ID 2 on the other router. If this key has got key ID 1 and the second key has got key ID 2, it should be exactly the same on other router also. I cannot have other combination. I cannot put the second key here and first key here. That's not going to work. The key ID also must match. And then every hello packet with authentication method and string. So during the runtime, if you change the password, the neighborship will break. It is not like once authentication is done, the second time authentication is only when the neighbor is re-established. Not like that. Even after forming neighbor, as soon as someone changes the password, the neighborship will break due to this mismatch in authentication. How do we know? How do we troubleshoot? This is the command which will give you a clue of where the problem is. Debug EIGRP packet. If you see like I'm receiving key ID 2 like this, one side it is key ID 1, the other side is key ID 2. That is the problem there. The key ID mismatch. The password may be same, but the key ID is not same. So the debug command will help you. Both the routers, you enable this debug command. This is receiving key ID 1, which means R2 is using key ID 1. And this is receiving key ID 2, which means R1 is using key ID 2. Mismatch. And sometimes key also mismatches. Key ID may be correct, but the key string itself is different. Then that same debug command will show you something like this, authentication mismatch. In the previous case, you did not see that word authentication mismatch. But here you see authentication mismatch or invalid authentication dropping here. Okay? So one single command you need to know to troubleshoot EIGRP authentication problem, that is debug EIGRP packet. Let's do this. Now we have neighbor, show IP EIGRP neighbor. There is neighbor between these two routers. I would like to sniff packet once again. Every 5 seconds, hello packets are sent with the authentication key. This is the packet coming from router 1 to the EIGRP's multicast address 224.0.0.10, and we can see here no authentication. Sorry. Let's go enable authentication. I think the configuration is not saved. Show run section keychain. Okay, there is no keychain. Let's configure. Keychain ABC. Key ID 1. Key string. I'll say key 1. And then key ID 2. Key string key 2. I'm applying to the interface. The interface name is F00. IP authentication mode MD5, mode for EIGRP 10. Did I use 10 yesterday? Okay, mode MD5. Next, IP authentication keychain EIGRP10 ABC. Done. So we are expecting neighbor to go down. Yeah, it is already down. I saw a log coming here as soon as I put MD5. Now go back to Wireshark and check the latest packet coming from. Okay, here it is. Router 1 says I'm using MD5. Look at this. Key ID is also sent in the hello packet along with the message tag. So key ID must match. On router 2, there is no authentication enabled. Let's go to router 2 and configure authentication. Okay, here it says the neighbor has gone down because of authentication failure. Let's put this debug IP EIGRP packet command, debug EIGRP EIGRP 10. Yeah. All right. So let's see. And the notifications will also notifications. Every 10 seconds, the hello packet should go and come. The debug that we saw in the presentation, is it somebody? Packets, debug EIGRP simply packets. No IP, they put EIGRP packet, fine. This is also okay. This will show all these. Okay, we can see here keychain missing. The one that is coming from other router keychain is missing. Null, there is no keychain. Ignore the packet from 10001, so router 2 says I'm not taking it. Debug EIGRP packet. Here it says ignore the packet from 2. The reason, here it is. The reason is missing what? Okay, here it is, missing authentication. You can see here missing authentication. Okay, I'll stop the debug. Coming from R2 with missing authentication is the reason for neighbor down. So going to router 2, creating keychain. Keychain name can be anything. I'm going to say XYZ. Correct. Key ID 1, key string. I think I gave key 1. And now I'll go under the interface F00 IP authentication mode for EIGRP10 MD5 IP authentication keychain EIGRP10 XYZ. Am I right? Did I give XYZ? Yes, XYZ. Done. Now the adjacency has come back. Going back to router 2's, okay, router 2 also has got, and you see message digest and key ID, both on router 1 and router 2 is same. Now let us do one thing. Let's go and change the key ID and see what happens. I'm on router 2. I'm going to keychain chain XYZ. I remove this key ID 1. Immediately authentication failure has come. I put keychain XYZ key ID 2 key string is key 2, key 1. Key 1 is the same password the other router also uses. It is key ID mismatch. So let's see here. R1 is having key ID 1 and R2 is having key ID 2. When the key ID mismatches, even the digest message digest hash value will also vary. Yeah. So let us debug and troubleshoot. What if I don't have a Wireshark to troubleshoot this? Debug EIGRP packet. Okay, here we see received packet is key ID 1, but locally key ID 1, there is no key defined for key ID 1. Locally we have key ID 2. Key ID 1 is not defined, so mismatching. Okay, now this time what we will do, we'll again go back to keychain. We'll have key 1, but the password will be key string key 2. Let's see what error we get now. This time key ID is matching. Both side key ID 1 is there, but key string is different. Debug EIGRP packet. It clearly says authentication mismatch. Key ID is there. Last time key ID 1 was not defined. Earlier when I checked it was saying not defined. But this time we have key ID 1 defined, but it is mismatching. Right. Fine then, this is how we can troubleshoot authentication. I'll stop this. We'll go back to our here. In a large environment, enterprises network environment, we may have hub and spoke design. What is hub and spoke design? We have one router connecting to multiple spokes, and the spokes have got many neighbors serially connected one after the other. And we may also have another path to reach the spokes like this. So this is like a hub and spoke. This is also a hub, and these three are spokes. Now to reach this network here, alpha, for the traffic coming here, it may be this way, or sometime it may be this way, depends on the bandwidth here. When we have hub and spoke design, there is need for some important consideration, which we are going to learn in this chapter. Before that, some introduction to understand this chapter. Factors that influence EIGRP scalability. What makes EIGRP slower? How to improve the scalability of EIGRP? Number one, we already learned summarization. Route summarization definitely improves the quality of the topology. How? When you summarize the route, the routing table is going to be smaller. Yeah, less memory consumed output. I showed you the other day, show IP route summary command. When you put summary command, you will see how much memory EIGRP routes have taken. So when you have less memory, when we have less memory and less lines of routes in the routing table, the time taken to process and the amount of CPU consumed all will be less. Summarization is very important feature that one should enable to improve the scalability of network. Not only for EIGRP, it's common for any routing protocol. Next is the number of routers that must be involved when a topology change occurs. Number of routers. When a change occurs, if only one router or the immediate router, two routers gets disturbed, it is okay. Usually when we don't summarize what happens, when you don't summarize, the number of routers that get disturbed when a topology change occurs will be too many. When you do summarization, only when all the network goes down, the summary route will go down. This point we saw earlier. I'll repeat. I have 10.1, 10.2, 10.3, and so on. And we summarize 10.000. If this goes down, will it disturb the next router? No, because we have summarized. Only when all these three goes down, the summary route will stop going and notification will be sent. You see, when you do summarization, the number of routers involved when the topology change occurs is less. So not only using summarization, there are various ways in which you can reduce the number of routers that will get impacted when a topology change occurs. One way is summarization, which you already know. There is another way which we will be seeing in the next page. But before that, depth of the topology. Same point actually. Number of hops that the information must reach. How many routers the information need to be sent when a change occurs. That's what it means, depth of topology. Fourth point, you see, number of alternate path through the network. When there is alternate path in the topology table, the scalability will be good than no routes. I repeat, you have a primary path. You also have a feasible successor path, backup path. When a primary path goes down, what will happen? The backup path will become primary. So the time taken to converge is very less. Very fast, the convergence happen. The packet goes through the new path. But what if I don't have a backup path in the topology table? I repeat, you don't have a backup path in the topology table, but physically there is a backup path. Because of feasibility condition, what is feasibility condition? Advertised distance should be less than successor value. Because that condition is not met, the alternate path is not considered as a alternate. So what will happen in such scenario? When there is no alternate path, in EIGRP table, there is no alternate path. Now, according to router alpha, to reach network A dot B dot C dot D, going via beta is the best path because the total FD is 40. The other route via gamma is not considered as a backup path. The reason is the advertised distance is not less than the successor value. So you do have an alternate path, but it is not a qualified alternate path for EIGRP. What will happen? If you have a qualified backup path, fast convergence, scalability is there. If you don't have a qualified backup path, physically backup path is there, but it is not qualified to be a backup path. So there is no entry in the topology table. When the primary path goes down, this will start querying and wait for the response. After that, only it can use the path. So time is taken much more time to add a new route into the routing table. It has to query, and when the response comes, the route will be added. These are all the factors that influence the scalability of this EIGRP infrastructure. Let's see how we can improve these things. This is what I just explained you. EIGRP querying process. Queries are sent when a route is lost and no feasible successor available. What does that mean? No feasible successor, meaning you don't have alternate path in topology table. So what happens when the route is lost? The route lost will go to active state. What does that mean? If you see EIGRP table, show IP EIGRP topology. 555, there is only one successor because we have different FT values. Now, what we were discussing is about the uh, alternate paths. I'll take a screenshot of this. Now, this is the primary route via router 2 has got the lowest FD. The one with this FD is the elected route, the only one successor. Now, we have alternate paths via 3 and 4. When the primary route goes down, R1 need not to query 3 and 4. It knows already that there is a path via 4 with this metric, path via 3 with this. It knows, so there is no need for query. It will immediately use path via router 4 as the primary. As soon as router 2 goes down or link connecting to router 2 goes down, it will start using this path. And when this also goes down, it will start using this path. But what if these paths are not a qualified path? Here it is qualified backup path. Advertised distance is lesser than the FT value, almost 2000 less. So we are having this. If it is not, then what happens when the primary route goes down? R1 will query R3 and R4 about path to reach 55555. It will ask, do you know route to reach 5555? During this state, during this place, this won't be P here. It will be A here. That is what it means, active. P means everything is smooth. Everything is smooth, going smooth. A means not really okay. I'm actively looking for an alternate path. I'm actively looking for an alternate path. So when the primary path goes down, if there is no alternate path in the topology table, this will go to A till it finds the alternate path. We call this time as struck in active state. See, it is in active state. It gets struck in active state, meaning it is trying to figure out the backup path. It's trying to find the backup path. Yep. So struck in active means what? When the primary path goes down, routers will query the other neighbors about the route to the destination if no backup path is seen in the topology table. That is what written there. Let's see again. You see, lost route is now in active state. Did you understand this line? The lost one. The இழந்து போன பாதையானது active state போயிடும். Until when? இழந்து போனதை மீட்கும் வரையிலும் it will remain active. Let me show you what does A means. You see here, A means active. P means passive. Right now it is good, passive, cool, settled, well settled routes. When there is no route, when it is querying for a route, it will be in A, active. Right. Now, third point, you see, queries are sent to all neighboring routers on all interface except the interface to the successor. In our topology, when path via router 2 goes down, will it query router 2? No, it will query all other routers. So it queries this guy, it queries this guy. Yeah, when router 2 path to reach 555 goes down, it will start querying the other neighbors, not the one which is lost. You see, that's what queries are sent to all neighbor routers on all interface except the interface to the successor, meaning the current successor, the one which went off just now. Next point. If the neighbor do not have the lost route information, queries are sent to their neighbor. This is where the problem starts. You see, let's say this is me, and this is alpha, and this is you, and this is they. Now, the path via alpha is the primary path to reach 1.2.3.4. But something went wrong. Alpha said, I'm no more a path to reach 1, 2, 3, 4. So what I do, me queries you and they. But the problem is you don't have a connection. You don't have a connection to 1, 2, 3, but you have connection to some other networks. You don't have connection to 1, 2, 3 for some reason. So if you don't have information, see, me querying about 1, 2, 3, 4, you don't know anything about 1, 2, 3, 4, so you send the query to your neighbor. If your neighbor don't know, your neighbor will send to its neighbor. The query keeps going. You see the depth. You remember we saw in this page. The factor that influence EIGRP scalability is the number of hops the information must travel to reach till it reach the old router, or number of routers that must be involved when the topology change occurs. These are the things that impacts the scalability. Now, when you don't know the route, you are not going to come back to me and say, I don't know. You're not replying me. I queried. When you don't know, instead of replying me saying, I don't know, you start querying your neighbor. Your neighbor starts querying neighbor, 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 neighbor. It keeps going until someone responds. What if no one has got connection to 1, 2, 3, 4? No one is going to respond. All will be querying and waiting for the answer. You see, if the router has an alternate route, it answers the query. For example, this guy, me queried them knows the route, them responds. But you don't respond because you have no connection to 1, 2, 3, 4. You see, if the router has an alternate route, it answers the query. This stops the query from spreading in that branch of the network. So if no query is, if there is no answer, the query is not going to be stopped. The query will be kept spreading all over the branch. And this is going to cause an issue. What issue? You see, me queried you as well as them. Them has answered me, but you have not answered. So what me will do, will it use the path given by them? No. It won't use the path given by them. Why? Me has also queried you. So it waits for you also to respond to take a decision. I repeat, me has queried two neighbors, you and them. Them has answered because them is connected to that network. You have not answered because you have no connection to 1, 2, 3, 4. But me cannot take a decision now. Me has queried two neighbors' response should be there in order to take a path selection decision. But me, though it has got an answer from them, it is still waiting for you to respond. Again, this is what called a struck in active state. It is still yet to decide the best path. It is still in active state. A, I showed you A. Yet to decide the path. Now, how can we solve the problem? Okay, how EIGRP solves the problem? By itself, EIGRP solves like this. EIGRP will wait for 3 minutes. 3 minutes it is waiting for you to respond. Will you respond? No way. You has no connection to 1, 2, 3. So after 3 minutes, this neighbor will be removed. Only then them given route can be used. After that, it will re-establish the neighbor with you. You see, unnecessary discard of neighbor. When a query is sent to a neighbor, if neighbor don't respond, after 3 minutes, even though the hello packets are peacefully going and coming, there is no problem with you and me, but the struck in active forces me to remove the neighborship from the neighbor list and re-establish the neighbor. Only then it can use the route given by them. See, if me discards the neighbor temporarily, what will happen, Immediately, topology change notification will go to all the router in that branch. They all will reprocess. And again, when me and you form neighbor, again the topology notification will go. Again, they have to process. This will make the EIGRP very busy, unnecessary busy. That's what we saw here. Number of routers that must be involved when a topology change occurs is too much here. This need to be controlled. If we don't control, this is what will happen. Is it looking nice to see? No. There's a big chaos there in the middle. You see how many arrows are going bidirectionally. That shows that, looping of queries and replies. It's just looping because no one knows the destination. No one knows the path to reach the network which is lost. There is a network called this. This was the primary path. For some reason, that has gone down. So B started querying all its neighbor. When the query goes here, if this C don't know what it will do, it will forward to its neighbor. So it comes down here. If this don't know, it will send here. It will send here. If this don't know, it will send here again. This is a big chaos. Query is simply rounding. So what is the solution? In the hub and spoke, this is very common. This is hub and these are spokes. How do we solve this? Solution I already told you here. What is the solution? When I query you, if you don't know, you should say I don't know. Instead of forwarding it to your neighbor, which will make you also to wait, me also to wait. And then 3 minutes after, we have to remove the neighbor, re-establish the neighbor. To avoid all this, we need to make this spokes router to answer whether yes or no. Simple. Problem solved. When a primary route goes down, B is going to query. You see? So need to see here. This is too much of messy. So to achieve this, what we need to do is we need to configure the C, D, and E to respond properly. We call it a stub, EIGRP stub. What does it mean? When you configure the C, D, and E as a stub, C, D, and E will go and tell B beforehand, before the query comes, before B sends any query, before anyone sends any query to C, D, and E, C, D, and E will voluntarily go to B and say, hello, B, I am capable of only these networks. If you have any query on these, come to me, I'll answer you. Rest, I'm not responsible. So when this network goes down, B knows whom to query because B got a stub information saying, I am responsible for these networks. In that network, if this is available, B will query C. Otherwise, B won't even send a query packet. முன்கூட்டியே பிக்கு தெரியுது யார்கிட்ட கேட்டா இதுக்கு ஆன்சர் கிடைக்கும், அவங்க கிட்ட மட்டும் கேட்கும், அவங்க மட்டும் ஆன்சர் பண்ணுவாங்க, ப்ராப்ளம் சால்வ். அதுக்கு காரணம் இந்த ப்ராப்ளம்லாம் வரதுக்கு முன்னாலே சி, டி அண்ட் இ என்னதான் என்னால முடியாதுங்கிறது தெளிவா போய் சொல்லிடுச்சு. This is what I can. So only when it comes in the realm of C, D, and E, B is going to query them. Otherwise, it won't even query. It won't send the query if there is no special information from C saying I'm responsible. Yeah. So that's what we see in this paragraph. What is EIGRP stub? The stub router send a special peer information packets to all the neighbor routers to report its status as a stub. எனக்கு இதுதான் முடியும், இதுக்கெல்லாம் நான் ஸ்டப் அப்படின்னா என்ன, இதெல்லாம் என்னால முடியாது, இதெல்லாம் தான் என்னால முடியும், இது சம்பந்தமா என்கிட்ட கேள் நான் சொல்றேன், வேற எதுக்கும் நான் பொறுப்பு கிடையாது. That is what that special pure information. So that makes the hub router whom to query, what to query, whom not to query. That solves the problem. So when a neighbor receives the packet informing that it is of stub, does not query the stub router for any routes. What does any route means? Any route that it don't know, whatever it is stub for. So it's like this. You're looking for a restaurant and you see a board vegetarian hotel, which means they are stubbed for chicken, mutton, beef. You don't go there because they are stubbed for chicken, mutton. They're stubbed. So you won't query. You won't go and ask, do you have semia with chicken paya? You won't ask. You will only ask idli with sambar. So you know what to query. Now in stub there are 5 types. In EIGRP stub we have 5 types. When you simply enable EIGRP stub, 5 types. When you simply enable EIGRP stub, you are enabling 2 type of stub. One is connected and summary. What is connected stub? The router takes responsibility only for the directly connected networks. So when I configure a router as a connected stub connected, for example, if I go to this router C and say EIGRP stub connected, when I put this command under router EIGRP, the router will take responsibility only for these 3 connected networks. It might have learned 1,000 networks from other routers. It won't take responsibility for those networks. Whatever learned from beta, C will not take response. It takes responsibility for only the directly connected. It will go and say, these 3 network only I am responsible for. If you have any query, I'll answer for these 3 network. That is stub connected. Next is stub summary. What is stub summary? If you will have a summary for some network, not connected. See, connected may be 192.168. Sorry, let us okay, no problem. 192.168.1.5/30. But you might have summarized 192.168.1.0. This is the summary of this. So when you say summary, it won't take responsibility for 30. It won't take responsibility for 30. It will take only responsibility for the summarized route, which is pointing towards null zero interface. When you say EIGRP stub summary, it will take responsibility only for those networks that is shown as summary route pointing towards, mostly, not mostly, always summary route should be pointing towards null zero. EIGRP will take responsibility only for summary route, not even connected, only for summary route. Whenever you say this, stub summary. But when you don't say summary or connected, it takes responsibility of both. C will say, I am responsible for this 3 connected network as well as the summary. So we have now seen default, connected, and summary. What is this static? When I say stub static, EIGRP stub static. If I will have a static route here, IP route L.K.J.H go via F00. So I have a static route for a network called LKJH. And I have redistributed the static route. Have you done redistribution? Okay, we will do. When we do redistribution into EIGRP, when we do this route redistributed into EIGRP, D will take responsible only for this particular LKGH network. EIGRP will not take responsibility even for the connected one. It won't take responsibility for its own connected. It takes only responsibility for this. See, depending on the requirement, we will enable any one of this stub. When you say EIGRP stub static, EIGRP takes responsibility only for those redistributed static route. I'll do the lab and show you in the next class. Now, what about this one? Receive only. Receive only will not take responsibility for any network. Receive only, if you say EIGRP stub receive only, it won't take responsibility for any network. It will simply say, don't ask me any queries. No questions to me. Simple. Hub router will not query. Yeah. So 5 types of stub in EIGRP: stub connected, stub summary, and stub receive only, stub static, and then by default it is connected and summary, right? That solves the problem of stuck in active. It won't now wait for 3 minutes and then discard and re-establish. The problem is solved. Yeah. So we will do this lab.